Okay, so let me introduce myself. My name is Molly Webb. I am the Geospatial Programs Manager and GIS developer here at WashU Libraries. I work out of the data services team. So we are all here to maybe learn a little bit about AI. I will admit I am not an AI expert, but I am someone who is enthusiastic about the possibilities of AI. And I feel like it's a good idea to kind of get to know at a really basic level, what AI actually is. So I'm going to start with this kind of technical definition here. A machine-based system that can, for a given set of human-defined objectives, make predictions, recommendations, or decisions influencing real or virtual environments. Okay, so this is a definition, pretty technical, from the National Institute of Standards and Technology, government agency. I like to think of AI as essentially giving computers the tools to complete tasks without being given explicit instructions. And so, in the true spirit of this workshop, I asked ChatGPT if it could give me a non-technical example of explaining what AI is. So, if you think about traditional computer programming and say you want to tell the computer how to recognize a car, like what is a car? So, some of the rules that you might tell the computer, okay, well, it has four wheels. It has a steering wheel and a windshield. Sometimes it has a roof, sometimes it doesn't. It weighs between, I don't know, 1 and 2 tons. I have no idea how much a car actually weighs, but you give it very specific information and instructions and say, here are all the things that need to be true in order for an object to be a car. That's kind of the traditional way that we would program computers to follow our instructions. With artificial intelligence, what we can do is the computer has the framework available. We give the computer millions of pictures of cars and trucks and buses and semis. And we say, okay, computer, this is a car, this is a car, this is a truck, this is a semi, this is a bus. The computer will essentially look at those pictures and it will figure out its own patterns of determining what is a car and what isn't. So imagine you have kind of an aerial photo like this. And you say, okay, the cars here in the traditional sense, you would say, okay, the cars here are about this long. They kind of look like this. They usually have a roof, and so on and so forth. All right. But there's a lot of varying things that can be happening with cars here. Sometimes they have sunroofs, sometimes they don't. There's lots of variations there. Trucks and cars actually look very similar from above, with the exception of the beds. Also, vans can look like cars. And so if we take this image and we mark it up and we say, okay, computer, here's a motorcycle, here's a car, here's a semi, here's a truck, here's a van, and we do this a lot of times, then with artificial intelligence, the computer can start to detect these patterns of what actually is a car. And hopefully, then if you give it another image, maybe like this, the computer would be able to say, oh, okay, yeah, car, semi, so on and so forth. But we might run into some issues. Like, for example, this image has some buses in it. The images before didn't. So the computer might not be able to recognize that. Another thing that I want to just point out is we actually have a car on top of a truck in this picture, which is another case that might be kind of confusing. So the computer might not be able to figure out everything here, but basically we're giving it an idea and it is trying to make its own decisions. So conceptually, it might look a little bit like this. We say, hey, computer, cars. The computer kind of gets its idea of what cars look like, and then it can say, oh, this is a car, this is a car, this is not a car. All right. Within artificial intelligence is kind of this subset called machine learning. And usually, when we are talking about AI, machine learning tends to be kind of what we're talking about here. And so, again, we're going to be giving the computer a lot of different information so they can kind of detect patterns and learn on their own. Now, we know the computer, they are just, machines that are built. So they're not actually learning, but they are recognizing patterns similar to what we do as humans. So another example here, we say, hey, computer, here's all this information about financial transactions. And what I want you to do is I want you to detect, okay, what are fraudulent financial transactions and what are legitimate financial transactions. So we'll give the computer millions and millions of records that are labeled okay, okay, fraud, okay, fraud, okay, fraud. And then the computer will go through a new set of transactions and it'll try to say, okay, we've got not fraud, not fraud. Okay, I found an transaction that looks suspicious, but the computer labels it not fraud. There is an okay transaction here that the computer labels as fraud. So the computer is not really getting everything correct. But then here is where the learning part comes in. So then as humans, we come in and we say, hey, computer, you got this one right, this one right, this one wrong, this one wrong. We give it corrections. And this process is both giving the computer information and re-correcting it is that process of learning, or sometimes you hear the word or the phrase training your model. This is what that is. And so then the idea is that hopefully the next time the computer can say, oh yeah, not fraud, not fraud. Oh, yep, this one is fraud. And then the final one in the lower right-hand corner is not fraud. Within machine learning, you have kind of another subset of calculating and processing instructions called deep learning. And for me, as an AI novice, this is probably the most black box thing for me. And I think that's okay. I think that's okay. We don't need to know exactly all the inner workings that are happening here. But within deep learning, what this is it's giving the computer tools to essentially process information at different levels, the same way that we can in our brains. So the idea of deep learning is trying to replicate that neural network that's here in our own brains in a computer so that the computer can look at information in lots of different ways. All right. So again, this is probably the most in the weeds concept, but the tools that we're going to be looking at today do take advantage of these deep learning frameworks. And it also requires usually some additional information. And that is what in the email that I sent you yesterday, I instructed you to download a new package of information that goes along with ArcGIS Pro. And those are these deep learning frameworks here. And we'll take another look at those in a little bit. All right. And so then generative AI is what I would say most of us has probably heard of when we've heard of AI. This is your Chat GPTs, your Claudes, your Google Geminis, the applications that essentially take lots and lots of information, videos, movies, music, computer code, images, and then you give it a prompt. It processes the prompt in natural language and tries to determine what you're actually asking it, and then it will produce something hopefully close to what you asked it to produce based on the information that it's been given. So what is a good AI presentation without a generative AI fail, right? I asked Google Gemini, I said, hey, can you give me an image of students taking a GIS class? Okay. Here is what Google Gemini came up with, which actually at first glance, I was like, hey, not too bad. I've been in tons of classes that look exactly like this. In fact, that instructor could be me, you know? Um, so I was like, not bad. I'm not sure what these maps are showing, but hey, no big deal. It's pretty close. Anybody see anything like weird with this? Alex, what do you see? You see three hands on one person. Okay. So, you've maybe messed around with generative AI on your own and answers or items that seem like they're pretty legit, they're probably pretty close, but make sure you do review these with a skeptical eye because we do have this human here with three hands, which I didn't see at first, but then I saw it and I was like, wow, okay, that's interesting. So yeah, no, I would say no AI presentation is complete without an example like this. This also tells us that we do need to be skeptical of any outputs that we're getting from AI, because obviously the computer can only give us outputs as good as its input data. And naturally, the computer has not completely replicated what a human can do just yet. All right. So now we'll get into GeoAI. So GeoAI is essentially all the stuff I just mentioned, but it is doing it within a geospatial context. So it's location aware. It's trying to perform some of the same operations that we do in GIS. So we've got our spatial brains and we think about stuff. We're trying to have the computer replicate those same things that we might be doing in a GIS. So one example of this is object detection. So if we're looking at satellite imagery and we can, look at it with our human brains and we say, oh, okay, we've got a house, we've got a pool, we've got some more houses, we've got some pools that are oddly shaped. Not all pools are rectangular. Also, we've got a tennis court that could kind of look like a pool from above. It's blue, but we see those lines on it and we think, oh, okay, that is a tennis court, not a pool. Then what we can do is we can take our brains and our fingers and we can start to digitize these objects. And we could say, okay, now I'm going to create a polygon layer here. It's going to have my houses and my pools and my tennis court. And I'm going to go ahead and add attributes to this image and these features that I create so that I can maybe use these features later on for some kind of analysis. Okay. And that's fine. I would say, like, as a human, we can do this pretty fast, depending on how accurate we want to be. But what if instead of one image, what if we have millions of images? Kind of like this. All right. So we all know there's a lot of satellites up in the air. There's a lot of sensors on planes and drones. And they are constantly grabbing information from either light reflectance in the form of photos or infrared data or any multitude of different types of information gathered, literally petabytes of information a day are being gathered. How can we as humans possibly get through and analyze all of that information? We definitely need the help of computers here. And using these AI concepts that we talked about are things that can kind of help us along. Are they going to be perfect at first? Probably not, just like our friend with three hands, but they are going to get us pretty close and they can help us kind of save some of this work. So we're going to be going through a few different examples today together. One of the ones that we are going to do together is going to be this land cover classification. So by land cover, I mean things like shrubs, trees, pavement, stuff like that. And so there is a model that we're going to look at that will help us kind of detect what these features are, and give them a classification in terms of land cover. And when we're running these tools, we're going to be running them just like we run other tools in ArcGIS Pro. So if you're already using ArcGIS Pro, you're actually most of the way there in running these tools. And when we run them, just like when we're running your traditional ArcGIS tools, we do have to be concerned about the parameters that we set. So when we're running these models, each model has kind of a different set of parameters that it makes available. And some of the ones that are common across all the models are things like batch size. So if we're looking at an image, how many, well, let's start with tile size first. So tile size will be the image, it gets broken up into chunks. How big are those chunks? And then batch size would be how many images does the computer process at one time? So your parameters and what you set them as are going to depend on the processing power on your machine, the time you have available, and stuff like that. Also, really important when you're running these models is to make sure that you're aware of the processing extent. So, your image might be big, like it might be for the whole state of Missouri, but really you just want kind of a tiny little portion. Say you're doing some analysis on WashU's campus. All right. So, in the Environments tab, you can set the processing extent to make sure that you're only processing the pieces of information that you need. Also, if you are needing to have a specific output size for the cells in your raster that come out of your model, you can set that here. And if you do have a GPU available on your machine, you can set up this tool to use a GPU as well. With these deep learning tools, you don't need a GPU, but they do run a little bit faster if you have a GPU. And that does lead me to another thing that I want to address is that kind of depending on, again, your processing extent, the resolution of your input data, these things are going to take a long time to run. I'm just going to flat out say that. All right. It's something that you should expect. I'm going to give some examples later on in the demos and tell you exactly how long it took to arrive at a specific result. But it's not uncommon for these tools to take 30, an hour, maybe even multiple hours to run, depending on your computer. If you're used to working with GIS, you may already be used to that. But just so you know, these things will take a long time. The examples that we're going to go through in class, I've specifically made them tiny, so it only takes us a couple minutes to run, and we're not sitting here and I'm not just like staring at you like this while the thing is running. But you should know that IRL, this is going to take a long time, right? Another example of a kind of pixel classification that we can do, we're actually not going to be doing this in class, but this is something else that's possible, is looking at floodwaters. So if you have an image of an area before a flood, and then you're able to get an image of that same area after a flood where the water is still present, you can detect the change in those two areas and pull out, okay, well, here was where the water was before the flood. Here was where the water was after the flood. Here are the areas that were most impacted by that flood. Another one, this is our tree point classification using LiDAR data. And so if you have a point cloud, then you can use a specific model to say, okay, I want you to find all of the points that are probably the canopy of a tree. And it can go ahead and point those out and specifically call those out in the point cloud if you don't already have that information. All right. So that's another thing that you can do. We're going to hit up trees a little bit today, but we're actually not going to be working with LiDAR data. We're going to be working with high resolution imagery. So then after you point out those trees, you can hope that the AI will do an okay job about pointing out the trees. But again, in this one, you can see, okay, we've got some green trees. All right, awesome. But we do have some edges of the buildings that it thought were trees. Incorrect, obviously. And so again, this is just to reiterate the point that you do need to look at the outputs with a skeptical eye. A lot of times this is not going to be the end of your work. It's probably actually going to be the beginning, is going through and then making corrections to the outputs. So what are we going to use as inputs for these tools? Well, the first thing that you need to kind of have available is a model that is specific for the problem that you're trying to tackle. So Esri's Living Atlas, which is their catalog of data layers and tools. They also have these deep learning models available, and there's tons of them. We're actually going to take a look at those ourselves here in a second because we'll need to download those so we can run those tools. But that is one thing that you're going to need to run these tools is a specific model. And Esri has made, I think at this point, they have 60 or so available for specific activities, specific tasks. And then the other thing that we're going to need is input data of some kind. Most of the models are going to ask us for high resolution imagery. Some of the models ask us to put in a point cloud. Some models require SAR imagery, synthetic aperture radar, which is slightly different from your standard imagery where the sensor is a camera just taking pictures or absorbing the reflected light off of a surface. Synthetic aperture radar is actually sending pulses down, and those pulses are returning back to the sensor. Synthetic aperture radar is usually very high resolution, and the key with that is that cloud cover, rain, storms, SAR data and SAR sensors don't care about any of that stuff because it's sending those pulses through all that information and getting it back up to the sensor. Whereas a photo on a satellite or a camera or excuse me, an airplane wouldn't be able to penetrate those clouds. So pretty handy there. Also, some of the models that Esri gives us and some models that are widely available, they can look at just kind of street level video and photos. And there even is a model that can pull out tabular data from PDFs, which is pretty cool. I haven't looked at it or tried it myself, but I'm intrigued. So I'll probably be looking at that one later. All right. So if you're interested in finding some of these types of input data, I'll invite you to go ahead and visit our LibGuide. And that has information on our geospatial data collection, as well as how you can log on to Living Atlas and get some of these other data sources. Slash, if you're looking for something in particular, I hope you will reach out and let me know if I can assist you in finding anything. So that concludes the formal presentation. The next thing I want to do is just take a look at that input box folder that I sent you. Okay. All right. So if you got to that box folder, you'll see we've got this zip folder that is our workshop data folder. I'm going to go ahead and download that now because I didn't. All right, so that's downloading now. And then also just noting here that you've got a PDF of this presentation as well as a resource guide with some other links in it if you'd like to take a look at that later. All right, so my workshop data folder has downloaded. I'm going to minimize all this stuff I've got on my screen right now. And I can see that a workshop data folder has downloaded as a zip file to my downloads. We're going to go ahead and start our actual demos here. So you can see I'm going to be kind of starting from the same place you all are. The first thing I'm going to do is start up ArcGIS Pro. You're going to get prompted to log in here. So make sure you click on your ArcGIS organization's URL. And if you are a WashU person, you're going to be typing in WUSTL to complete the URL wustel.maps.arcgis.com. Hit continue. You'll be presented with this blue button, Washington University. Go ahead and click that. And now this is going to ask us for our WashU key. All right. So now that ArcGIS Pro is up, we're going to go ahead and start a new project. So I'm just going to click on Map. It's going to prompt me to enter some information here. First and foremost, I want to make sure that I'm saving this project someplace that I'm going to be able to find it later. So for me, let's see where I'd like to save this. I think I'm going to save this to my desktop. So I'm going to say that this is going to be my new project location. And why don't I go ahead and create a folder for this project? I'm going to call this GeoAI Workshop. And this will be where I'm going to put all my stuff for my workshop today. You can just go ahead and right click and create a new folder right from within this window if you need to. And just to reiterate, to get to this location, I just clicked on that yellow file folder icon. Okay, so at my new project, again, I created a folder for this. So now I just need to give my project a name, and I will give it the same name. I'm going to call it GeoAI Workshop. The last thing I want to mention is since I just created a folder for my workshop, I'm going to uncheck the button for create a folder for this local project because I already created one. I don't want another one. Let's go back over to Windows Explorer here. And in my downloads folder, I'm going to right click on my GeoAI workshop data zip file that I just grabbed. I'm going to go ahead and cut. I'm going to go back to my desktop, navigate to my GeoAI workshop folder, right click and paste that zip file there. All right. Another thing that I'm going to do while I'm here in my project folder is we're going to download some of those models from Living Atlas. So I'm going to create another folder so I can keep those models there, have everything nice and organized. So here I'm going to right click in a blank spot on my Windows Explorer. I'm going to go to New and Folder, and I'm going to create a new folder here right within my project folder. And I'm going to call this one Models. I should say you can name these folders whatever you want. They don't have to be the same thing that I'm using, just so you'll be able to find them later, is kind of the key. Now that my zip folder is in my project folder, I'm going to right click on that folder. And you could do a couple of things to unzip this. You can either go to extract all, and that's the built-in Windows file extractor. If you're working on a lab machine, you also have 7-zip installed here. So you could go to 7-zip and extract here. That's going to extract that zip file right to the project folder. I'll go ahead and do extract all just since that's what all Windows machines have. And I want to make sure that I am saving this to the right place. So right now, what's going to happen is the destination is going to be my GeoAI workshop folder and another folder called GeoAI workshop data. Well, what I'm going to do is I'm going to get rid of this GeoAI workshop data folder because the zip folder is a folder in itself. And so if I don't get rid of that GeoAI workshop data folder, I'm going to have one folder called GeoAI workshop data. And then within that folder, I'm going to have another folder called GeoAI workshop data. So again, just taking a couple seconds and talking about the structure of our project can save us some time in the long run. Okay, so when you have that path all set, you can go ahead and hit next, and then that's going to extract. Another kind of file management thing, since I no longer need this zip folder, I'm going to go ahead, or excuse me, it's a zip file. I'm going to go ahead and right click and say delete because now that I have unzipped that information, I don't need that zip file anymore. And so again, I'm trying to keep my workspace clean here. And so getting rid of that zip file is just part of that. We don't need to keep a ton of stuff around if we don't need it. Okay. So moving back over to ArcGIS Pro now. In the catalog pane, If I expand folders, we're going to see my GeoAI workshop folder there. And if I expand that folder, I'm going to see everything that is within that folder, including our GeoAI workshop data folder that we just unzipped, and also that models folder. Now, if you're not seeing those items in your GeoAI workshop folder, you can always right click and go to refresh, and that's going to kind of reset what we're seeing there. Also, just of note, if you're not seeing the catalog pane on the right-hand side, you can go to View and then Catalog pane right there. That'll let that catalog pane pop up for you. All right. So let's go ahead and take a look at that input data that came from Box. So I'm going to navigate to my GeoAI workshop data folder, and I can see that within this folder, I've got two geodatabases. We know that ArcGIS Pro likes to work within a geodatabase. It's the proprietary data format for Esri, so that's what we're going to be using today. There's lots of other spatial data formats out there, including non-proprietary ones. And that actually does remind me of something else I was going to mention that I forgot, and that is ArcGIS Pro's AI tools are not the only AI tools out there available for us to use. There's lots of different tools for us to use. Some are open source and some aren't. Of course, these ArcGIS Pro tools are not open source. We need Esri licensing to be able to access them. But since most of us are associated with WashU, this workshop is for WashU community. So we are going to be using the Esri tools. They have them just very nicely packaged up for us to use. And like I said before, if you're already used to using ArcGIS Pro and running tools, this is going to look very familiar to you. Another thing that I want to note is that in ArcGIS Online, which is the web-based web mapping platform from Esri, they do have some of these deep learning tools available in that platform too. The difference is that it does consume credits whenever you're using those processing tools. And so if you're doing super large data processing, you probably want to be on Pro because it doesn't consume credits. And also you can make mistakes without running through your organization's bank of credits. All right, so let's take a look at these inputs. I'm going to expand my GeoAI workshop inputs folder and take a look at what we have here. So let's start at the top here. We've got Olin Imagery half inch, Olin Library AOI, Olin Library North Bike Parking, and WashU Imagery 6-inch. So what I'm going to do is I'm going to click this first one. I'm going to hold Shift and click the last layer there. So they're all selected. I'm going to right click on my selected layers and I'm going to go to Add to Current Map. Once we do that, it's probably going to take a couple seconds for that data to load, but it's going to zoom right into the study area, the extent of these layers here. Another thing you could do is you could just click and drag each one of those into the map window as well to get all of those in. Let's take a closer look at what we have here. Starting with this WashU Imagery 6-inch layer. So of course, if you are familiar with WashU's campus, this probably looks familiar to you. This is WashU's campus, and the imagery here is at a resolution of 6 inches, which means that each pixel in this image is the equivalent of 6 inches on the ground. So this is considered pretty high resolution imagery. And this is saved to our geospatial data collection, which you can go to that LibGuide and find out how to access that. So that's our WashU 6-inch imagery. And then the other one I'd like to show, I'm going to turn off the WashU 6-inch imagery for now. I'm also going to turn off these two polygon layers for now and focus on the Olin imagery half-inch. So I'm going to right click on that layer and go to zoom to layer. And so this is a even higher resolution image of basically the top of Olin Library, the building that we're sitting in right now. This imagery was gathered from a drone. The resolution of this image is approximately a half inch, maybe even just a tiny bit bigger, but half inch is a nice round number. So super, super high resolution imagery here. Okay. The next layer we'll look at is this Olin Library AOI. So I'm going to right click on that one and zoom. And so this is basically just a polygon giving us an area of interest around Olin Library. I'm going to click on the patch of this layer and set it to a black outline so we can actually see through it. All right, we're going to do the same thing with that bike parking layer. I'm going to turn it on in my table of contents, or excuse me, contents pane. It's going to be just a little polygon that appears just to the north of Olin Library. It's just the extent of the bike rack we have there. So I'm going to do the same thing. I'm going to click on the patch. That's going to open up the symbology pane for that layer. And then here I can either use the gallery to choose a pre-made symbology, or I can click on properties and set the symbology more specifically if I want. So color, that's the fill color. I will set that to no color. And then outline color, let's make this one, I don't know, something else. I can also bump up that outline width too. You don't have to be setting this exactly to the colors I'm using, just set them to whatever colors you want. All right, so I've got my area of interest for the library here, and I've got my area of interest for the bike rack. These polygons here are just to help us with our data processing, so we can use these as the processing extent so that our models will run a little bit faster during our demos. All right, before we go to Living Atlas and download our models, I want to just show you a little bit about how you can get information about any input rasters that you have or input imagery. So going back over to the contents pane, I'm going to choose one of my imagery layers. Let's just start with the Olin imagery. I'm going to right click on that layer, and I'm going to go to properties. This opens up the properties screen. Again, in the contents pane, I'm right clicking and I'm going to properties and opening up the properties window here. In the properties window, I'm going to go down to the source tab and click on that. This is a pretty important place to be aware of in ArcGIS Pro for a couple reasons. Probably most importantly, it tells you where this file actually lives on your machine. And so when we're dealing with raster imagery here, we can expand this raster information area. And this tells us some pretty crucial information about this raster. It tells us the number of bands. And this is getting a little bit into kind of how this data is structured, but essentially a band is kind of like a layer of information contained within this raster. And then probably the most important one is this cell size here. So we have a number, cell size X, cell size Y. So that's the dimensions of the cell. But what does this number actually mean? Like, what are the units here? If you just scroll up a little bit under data source, it tells you, oh no, sorry, not right there. That's vertical units, sorry. If you scroll down a little bit and go to spatial reference and expand that, this tells us the spatial reference of this, this data set. And within here, we're seeing a linear unit there. So that is the unit that the cell size is referring to, all right? So the cell size is referring to a 0.04, basically a 0.05 of a foot, which is about a half inch. So that's how you can tell. Okay, let's do that same thing and let's look at the properties for that 6-inch imagery. So I cancel out of there. I'm going to right click, go to properties, make sure I'm on my source tab, expand raster information. Now this one is telling me that the cell size is 0.5. Okay. If I extend the spatial reference section here, this data set has a linear unit of a foot. So the cell size is 0.5 of a foot, half a foot, 6 inches. Okay. All right. So that's how you can tell what all that means. Now, why is that important? All right. Well, I'm going to tell you right now. We're going to pause on ArcGIS Pro just for a moment. Please go back to your web browser. And I'm just going to open up a fresh search tab here. And I'm going to search for Living Atlas. And so what I want is the ArcGIS Living Atlas of the world. I'm going to click on that. So Living Atlas is essentially a catalog of data, models, scripts, things that Esri has put out there to be consumed within their products and also maybe other products as well. But this is where we can find the models that we were talking about. So essentially the information that we're going to give to the computer to say, here's how you do the thing that I want you to do, we're going to grab it from here. So in the Living Atlas of the World search bar, I'd like you to type in DLPK, okay? DLPK. That is the file type of the images that we're going to be pulling. And so if we search for DLPK, that is going to pull up a list of all of the models that are available for us to use. We could also search for Esri_analytics. That's the owner of all these models. But for me, DLPK is a lot easier to remember. So I usually just search for that. If you're searching for a specific model, like you want to do building footprints, you could always search for building footprints and it would probably also pop up. But I would like to show you all the full list of models here. So DLPK, hit enter on that. And so that is going to pull up all of these different models. So remember how at the beginning we were talking about giving the computer information and how to find what we wanted to find? So all of these models here have been trained to find a specific thing. They're trained for a specific purpose. And so Esri probably takes information from its users and it says, here is a model that we want to make. And it makes this model available. So it's always a good idea to kind of scroll through and see what kind of models are available here. So the very first one that popped up for me was this building footprint extraction one. And that's actually what we're going to be starting off with first. So I'm going to click building footprint extraction. And it's going to take me to a detail page about this particular model. Now, I would go ahead and read all of this, not right now, but if you're going to use this model, just familiarize yourself with kind of the ins and outs of this model. They do give you pretty explicit instructions on how to use it. But specifically, I want to point out this portion here, input. All right, so this input here tells us what kind of input data that model wants to be able to run. So it's saying it wants an 8-bit, 3-band high-resolution image that's between about 10 and 40 centimeters per pixel. If you go to using this model and you click on guide, this basically will walk you through how to use the model, and it tells you what tool to use also within ArcGIS Pro. So it's always a good idea to check that out too. So like many Esri things, their documentation is really solid in terms of step-by-step instructions on how to use this. I want to download this model, but so far I'm not seeing any method to download it. And that's because we actually do need to sign in to the WashU AGOL organization to download this model. So we're going to click sign in at the top. The very familiar ArcGIS login screen is going to pop up. Now, do not type in your stuff right here, WashU folks. Expand your ArcGIS organization's URL. Type in Woostle to complete the URL, woostle.maps.arcgis.com. Hit continue. Click through to maybe your WashU key entry page will pop up. If you're already logged into something else, maybe it'll pass through, but you might need to enter in your WashU key. And now that we're signed in, now we have this download button. So go ahead and start that downloading because that might take a couple minutes. I'm going to pop back over to ArcGIS Pro because I remembered one other thing that I forgot to tell you. So in my email message to you last night and earlier in our talk today, I mentioned the extra files that you have to provide to ArcGIS Pro to be able to run these tools. Those are the deep learning packages. And I do have those pulled up here. You can just Google deep learning packages or deep learning frameworks for ArcGIS Pro, or you can follow the link that I sent you in the email. And this walks you through installing the deep learning frameworks. Now, it actually does point you out to this installer page, which is a GitHub page. And if you scroll down a little bit, here are all the downloads that are specific to your ArcGIS Pro version. So right now, it's showing version 3.5, which is the version on these lab machines. Here are some previous releases if you have an older version of ArcGIS Pro. And so when you are installing these on your own machine, make sure that you download the installers for your ArcGIS Pro version. If you're not sure how to check your ArcGIS Pro version, I'm going to show you right now. So back to ArcGIS Pro. Since I'm in a map window right here, what I'm going to do is I'm going to click on Project up in the upper left. This is going to kind of take me to my home screen, if you will, on ArcGIS Pro. If I go to About, this is where I can see my ArcGIS Pro version. So right here, I am on version 3.5.4. If you're using your own machine, you might be seeing a different version. And also just of note, don't do this right now, but you can also update your version within ArcGIS Pro here. You don't have to install anything else. It does it right within. After I've installed those deep learning packages, I can double check that those are installed properly by going to the Package Manager tab. That's going to open up essentially all of the underlying Python and R and other things, libraries that ArcGIS Pro is using. And in the search bar, I can just type in deep, and we should be seeing this Deep Learning Essentials library. That is one of the libraries that gets installed when you install those packages. So if you're on your own machine and you don't see that, that means that the deep learning packages are not installed in your ArcGIS Pro version. Okay, so those are just some ways you can check. Okay. Next, I'm going to go back to File Explorer because I'm going to grab that model that I downloaded and I'm going to save it to my project folder. So I'm going to open up File Explorer. I'm going to go to Downloads. There is that .dlpk file that I downloaded. I'm going to right click and I'm going to cut that file. Then I'm going to navigate to my desktop, to my GeoAI workshop folder, to the folder that I created to hold my models, and I'm going to right click and paste that model in. So again, just taking those few couple seconds and making sure that all my files are nice in my project folder. I'll be able to save them later or find them later. It just takes a couple extra seconds to move stuff around. Keep your workspace clean. Okay, now that we've moved that file over, let's go back to ArcGIS Pro. From my home screen here, I'm going to hit the back button in the upper left-hand corner and get back to my map. So now what we're going to do is we're going to search for our geoprocessing tool that we're going to use, and we're going to try to extract some building footprints from this image here. Okay, now we are not going to use this high resolution image of Olin. We're actually going to use the 6-inch image of WashU's whole campus. So I'm just going to turn on the 6-inch image and I'm going to turn off that Olin library image. And I'll tell you how long it would take if we actually used that Olin image. Way much longer than we have for our workshop today. Okay, so to find our tool, we're going to go to the analysis menu up at the top of our screen. This is going to open up the analysis ribbon. We're going to click on tools, and that is going to open up the geoprocessing pane on the right side of our window. In the geoprocessing pane, we are going to search for detect objects. And we are going to choose this top result, detect objects using deep learning. So again, I went to the analysis menu at the very top. Once the analysis ribbon was up, I clicked on tools, the toolbox icon. That opened up the geoprocessing pane in the search bar. In the search bar, I searched for detect objects, and I chose the top result, detect objects using deep learning. Okay. All right, so for input raster, I'm going to click this drop down and I'm going to choose the WashU imagery 6-inch layer. Now, remember when we looked at the inputs for this tool and it said that it wanted a 3-band image and not a 5-band image like this one is? Well, I did some testing on this, and truth be told, the results are the same, whether you have a 5-band image or a 3-band image. So I was going to walk you through the process of extracting the bands, but we're going to skip that because honestly, the results are the absolute same. It still runs fine. So we're just going to move forward just with this imagery as it is now. Okay. For output detected objects, let's click on the yellow file folder icon here, and it's going to default take us to the GeoAI workshop.gdb. That is the default geodatabase for this project that gets created when we create a new ArcGIS Pro project. So we're going to save our outputs in there. And I'm just going to call this building footprints. You can call it whatever you want, just as long as you know, hi, come on in, just as long as you know what it's going to be and you can find it later. Okay, so building footprints within our geodatabase. And then next up, we're going to input our model definition. Now, this is where we're going to go to that model that we just downloaded. So click on the yellow file folder icon. Over on the left-hand side, we're going to navigate to this PC and desktop, and essentially we want to navigate to our project folder and that models folder that we created. So it might take a couple seconds to get back there to wherever you saved your stuff. But ultimately, we want to find that DLPK folder or DLPK file that we downloaded before and saved to our project folder. This is why we save to us, stuff to our project folder so we can find it easily as we're working. All right, so I'm going to select that DLPK file. Now, it's going to have to load some information here, so it might take a couple seconds. We're seeing kind of a little blue dot go across the top of our pane here. That's just telling us that it's loading that in. Once it loads, we're going to see some options here under this arguments section. And this is those arguments, or I called them parameters earlier, where we can set things like batch size, tile size, and so on and so forth. So in the argument section, this is where you can basically fine tune your model to run either more precisely or maybe a little bit less precisely. And if you're curious as to what these arguments mean, you can just hover over the blue information icon, and this gives you a description of what all of these parameters are. So if you don't get a desirable result with, say, your first run, just using the defaults, you can start to tweak these parameters and see if you can get a little bit better output. Okay. So for the parameters section, this is all we're going to do. We are going to go to the environment section here. So just click on that other tab right at the top of the tool. For output coordinate system, we're just going to drop down and say current map. So that means our output polygons are going to have the same coordinate system as our input data. And then, very important here, unless you want to be sitting here for a couple hours, is setting up this processing extent. So we can either use the little globe square icon and say only process what we're seeing on the screen here, or we can use a polygon area of interest as well. In the third icon, extent of a layer, we can click this drop down, and we're going to say Olin Library AOI. All right, so I just clicked on the little yellow icon, extent of a layer, and I chose AOI. So this tells the computer, okay, only process the image just inside this polygon. Okay, so with all of our parameters set and our inputs and our display extent, we're finally ready to hit run. And we're going to get a little kind of progress bar down here at the bottom. Now, hopefully this one in my trials took me about a minute. So we'll see with this laptop, we'll see how this does. When I ran this on the entire WashU imagery layer that you have, it took a couple hours. So if this gives you any indication as to how long these can take. The WashU imagery layer, if I right click and zoom to it, is not super big. I mean, it's maybe a mile across. It still took several hours to generate all the building polygons here in this layer. So like I said before, just be ready because these things are going to take you a while depending on your study area and the resolution of your imagery. So once your processing finishes, depending on your computer, you may see some yellow text and a little yellow triangle with an exclamation point, okay? That's a warning. It's okay. It's not a failure. It's not an error message. It's a warning. And so this is just telling us, it's going to basically tell us some information about the computer itself. It's a CUDA error. It says CUDA something, blah, blah, blah. Yeah, so that's just telling us a little bit about it can't find a certain thing on the computer, but it didn't prevent us from running the tool. We still got an output. So we're just going to ignore the error. Okay, so mine finished. Now I have a layer called building footprints in my map. Let's do a right click and zoom to layer. All right, so let's see how we did. Okay, I'll be the first to say not great, but not horrible. All right, not bad. Let's see how much mine took. Mine took 1 minute and 50 seconds, so just slightly longer. Okay, so we have some building polygons here. Again, like I said, not perfect, but it gets us some of the way there. You can imagine if you were doing this for a whole city, this might be a pretty good start. Plus, you can incorporate the results of this with results from other models. So hopefully, eventually, the computer will help you get a full picture here. Now, one thing I am seeing is I'm seeing a lot of these um, like overlapping polygons. And so what we're going to do is we're going to just run another geoprocessing tool. This isn't a deep learning tool. This is just within straight up ArcGIS Pro, but we're going to just do a little bit of work to kind of clean up these polygons a bit. So I'm going to, in my geoprocessing pane, I'm going to hit the back button here a few times to get us back to the geoprocessing search bar. And here I'm going to search for dissolve. Okay. Now, the first tool that pops up is going to be the dissolve tool. We're actually not going to use that because the dissolve tool would essentially dissolve all of these buildings into one feature, and that's not what we want. What we're going to do is we're going to choose this dissolve boundaries tool. So this is the third option here that popped up for me. So for dissolve boundaries, our input features, let's click that drop down, and our input features are going to be our building footprints. Output feature class, I'm going to click on my yellow file folder icon. It's going to take me directly to my geodatabase for this workshop. But if yours does not do that, go ahead and just go back to your project on the left-hand side, click on databases, and your workshop folder, or excuse me, geodatabase will be there. Or you could expand folders and get to that geodatabase there too. There's a few different ways you could get back to it. For this output layer, I'm going to call it building footprints dissolved, just to differentiate it. And I'm going to hit OK. So that's going to be my output. And all the other things I'm going to leave as the defaults, even on the environments pane, because this is going to take the same coordinate system as the input layer, which we already set to the state plane using our map. Okay, so I'm going to hit run. Hopefully that'll just take a couple seconds. For me, it took about 30 in my trial run here. Okay. All right, so mine finished. I've got my building footprints dissolved layer now. I'm going to uncheck my previous one. And now I can see that these polygons are a little bit cleaner. We don't have a lot of polygons on top of each other. And so we're basically just taking the starting output that the deep learning tool gave us. We're running a little bit more processing on it to make it a little bit cleaner. So we're actually going to go on to our next model. All right. So please go back to your web browser. And I'm going to find my Living Atlas tab here, okay? Or you can always go back to Google and search Living Atlas, but essentially we want to get back to this page with all the models on it. And the next thing we're going to do is we're going to run that land cover detection. So you can either scroll down and find land cover, or you could hit Control Find on your page and just type in land cover. Now, I do want to note that there are several land cover models available here. So we want to make sure we're choosing the right one. There's a land cover model for Landsat imagery and for Sentinel-2 imagery. And then also, what we want here is this high resolution land cover classification USA model. All right, so make sure that you're going to this particular model here. This is the one we're going to use. So High Resolution Land Cover Classification USA. So this model is specific to, of course, the United States. It may not work as well in other areas. And specifically, this tells us that the model applies to the United States, but it produces the best results in the Chesapeake Bay region. So guess where they trained this model? Probably on the Chesapeake Bay region. It tells us that it wants that 8-bit 3-band imagery. We're going to go ahead and just use it with our 5-band imagery. So again, it might prompt us to sign in again to download the model. So go ahead and go through that process. Hopefully you won't have to enter in your credentials again. Hopefully it'll just pass through, but you might need to log in again. And then go ahead and click download. While mine is downloading, I'm going to check the using this model guide. And this guide is going to tell us that this model is good for using with the classify pixels using deep learning tool. So that's the tool we're going to use. All right, so my model finished downloading. Anyone want to take a guess as to what the thing I'm going to do next is? Anyone?
Processing, search, classify pixels using deep learning.
Almost. Before that.
Oh, copy.
Yes, exactly. Data management, people. Okay. I'm going to go to my downloads. I'm going to grab that file that I just downloaded. I'm going to cut, go back to my desktop, and save it to my models folder. We are not going to let that file be orphaned in my downloads folder. We're going to make sure we keep it with everything else. But then what is the next thing we're going to do then? Exactly. Yep. So the next thing we're going to do is we're going to search for that geoprocessing tool. So let's go back to ArcGIS Pro. Let's hit the back button to get to our geoprocessing search. And we're going to search for the classify pixels using deep learning tool. Okay. All right. For input raster, we're going to use our WashU 6-inch imagery here. So click the drop down for input raster and choose WashU imagery 6-inch. Now the output of this is not going to be polygons. The output of this is actually going to be another raster where each pixel has the value of the land cover type that the AI model has applied to that pixel. So I'm going to click on the yellow file folder icon. It's going to take me to my workshop geodatabase. And I'm going to name this land cover WashU. You can name it whatever you want. And then model definition, click my yellow file folder icon. Now I'm in my models folder here, but I'm noticing that I'm not seeing that file that I just saved. All right, that's no problem. Up in the top text field here, there's a little refresh button. Go ahead and click on that refresh button, and that's going to go through and look and see what files are in that folder and display them for me. So I'm going to choose that high resolution land cover classification tool, or excuse me, model, and hit OK. That's going to go through, it's going to load up all those parameters just like our previous tool did. Okay, so that one took much less time for me than the previous one did. But here's all those different arguments that we can set. We're going to leave those alone for now, but feel free to play around with them if you want later. I'm going to click on my environments tab. I'm going to make sure that my output raster is the same coordinate system as my map, which is going to be State Plane, Missouri East. And again, for processing extent, I'm going to use the extent of a layer dropdown. And I'm going to, again, choose Olin Library AOI. So that's going to limit my processing extent to just our area of interest around Olin Library. I'm going to go ahead and hit run on mine because it's going to take about um, 3 minutes. Hopefully, that's what it took in my testing. While this model is running, let me tell you how long it took me to run some of the other study areas. Okay, so using this same study area, but using the half-inch imagery, doing the land cover model, it took about 1.5 hours. And then doing land cover on the entire WashU study area, the one that I showed in the presentation, took about 2.5 hours. All right, so it is going to take you a little bit of time. I got a result here nicely clipped to my area of interest. So I'm going to uncheck my building footprints and I'm going to take a closer look at my outputs here from this model. So let's see how we did. Again, I'm going to say okay, not perfect. Let's turn off that bike parking. Now, what I can do is if I want to look and see features underneath this raster, I can set a transparency here. With my raster layer selected in the contents pane, I can go up to raster layer up at the top and then set the transparency here if I just set it, say, to 50%. So we can see the features underneath. Okay, so again, with that layer highlighted in my contents pane, that's going to pull open the raster layer contextual tab right here. And if I click on that, then transparency is just almost right underneath that raster layer tab. All right, so let's see. It grabs some of these trees, which is okay. It definitely pulled out this top structure for structures, but it thinks that the rest of the roof of Olin Library is shrubland. Okay. It caught this building right here as a structure and it caught this tree. So again, not perfect, but it does get us some of the way there. Maybe we could take this output, combine it with this output and get even closer. Okay. All right. Shall we do another one? Okay, let's do it. Go back to Living Atlas. Okay, this time we are going to look for tree detection. So I'm just going to, again, do kind of just a Control F on my page and search for tree. There's a couple that are going to pop up here. This tree point classification is one of them. That is actually not what we're going to use today. What we want to use is this tree detection model here. So detect trees using high resolution imagery. Okay, so let's go ahead and do the sign in to download this. We're familiar with this process now. And get that downloading. Okay. So I'm back in ArcGIS Pro now. Let's double check the tool that it wants us to use. Okay, by looking at the guide. and it would like us to use this detect objects using deep learning tool. Okay, so that's the same tool we used before. We're just using a different model here. And so it's going to be looking for a different thing. All right. Now, this is where our other area of interest is going to come into play here because again, this is going to take kind of a long time. And so we want to use just this smaller Olin Library North bike parking area of interest. And we're actually going to bring in uh, our high resolution, even higher resolution imagery, the Olin imagery half inch. Okay. So just being conscious of the time here, I do want to make sure that we can get through this one and the next one. So I did a little bit of a cheat here. You probably noticed that when you downloaded the data, there was both an inputs geodatabase and an outputs geodatabase. Well, I decided to take a little bit of like a cooking show approach here, and I actually provided you with all of the outputs from the model runs that we've already done. So in the interest of time, I'd like to just bring these in and take a look at them. And then of course, feel free to actually run the model if you want to run the model. But I'm going to show you a couple things. So the first one I'd like to show you is the trees from half inch. So if we go to the geoprocessing pane and we go back to that detect objects, all right, so do that. Hopefully my model has downloaded by now. So I'm going to go back to my web browser. Okay, I can see that's downloaded. Let's open up File Explorer and check my downloads. Okay, that's there. So I'm going to do the same thing. I'm going to take it from my downloads and I'm going to put it into my models folder. So now the model lives with all the other models. If I go back to ArcGIS Pro, my input raster is going to be my Olin imagery half inch. My output objects detected, I'm going to call this trees from half inch. I will bring my model in. Oh, again, my model's not showing up just quite yet. If I hit the refresh button, there it is. Tree detection. Okay, all the same steps that we did before. Set my environment, processing extent. This time I would set it to this Olin Library North bike parking extent. Okay. At this point, I would go ahead and hit run. It would take about 20 minutes. And then I would get something like this. In my outputs geodatabase, trees from half inch, I'm going to go ahead and click and drag that into my map. All right. Now, in the computer's defense, I will say that these trees are pretty sparse. We specifically said, hey, model, I only want you to get these trees right here. Of course, there's some nice full trees right here that I'm sure it would pick up if we told it to. If we look closely, we can see that it definitely caught these bushes. Nice bush detection, yeah. So anyways, again, I wouldn't suggest just using these results. Maybe run the model a few times, combine it with some other results, and then you can get a more complete picture of what we're looking at. Now, I ran this model again on some other imagery that's publicly available. So if you are not already familiar, the state of Missouri has a really solid geospatial data clearinghouse called Missouri Spatial Data Information Service, or MISDIS. I'm going to show you where that is by going to a web browser, pulling up a fresh search tab, and I'm just going to search for MSDIS. And MSDIS is kind of the casual name. The first result here that pops up, MSDIS. And so this is a clearinghouse where many different state agencies, state government, local agencies contribute their data to this clearinghouse. And this serves as the distribution point for the public for all of that data that's being generated by the state agencies. So the state agencies don't have to distribute this themselves. They give it to MSDIS. MSDIS distributes it. So anytime you're looking for data about Missouri, this is a great place to start. You can look at their open data portal, or if you're looking for a specific area, you can look at the Missouri map to find imagery and elevation data. Just in the interest of time here, I'm going to click on web services. And then they've got a few different web services here. Now, our 6-inch imagery that's available through WashU is just for the St. Louis region, but MSDIS does have 6-inch imagery for the entire state. It's slightly older than the version that we have, but it's still very solid imagery. And so you can, if you're looking for study areas outside of Missouri, you can look here. I'm going to click on other imagery services, and this pulls up what we call a services directory. So this is basically just like a list of folders and files, just like we have on our machine. I'm going to click into the MSDIS section, and I'm looking at this NAPE imagery here. So NAPE is a government program that flies high resolution imagery for a large chunk of the United States every year. It's not as high resolution imagery as, like, say, what we have, the 6-inch imagery, but it's not too bad. And I'm going to choose this MSDIS NAPE 2024 service. Now, when I grab this service here, it takes me kind of to this landing page. I'm going to copy this whole URL up here at the top. So highlight it, select it, right click, copy. Now I'm going to go to ArcGIS Pro, and I'm going to, at the top, go to my map tab. On my map tab, I'm going to find the add data section and click that add data drop-down menu. And then I'm going to click from path. So add data from path. This is going to give me a text box to input some information. And so here I'm going to right click, paste, and paste that URL right into this box. So this is a great way to bring in information into ArcGIS Pro. If you can find these web services, you can bring in the data just from a URL. You don't have to download anything. And this is essentially like streaming data. Like we stream stuff on Netflix. Here we're going to stream some imagery. All right. So I'm going to click add. And this is going to add in this imagery here. Now, again, I said it wasn't going to be as high resolution. So again, we're talking pretty pixelated here, but we can still see some tree-like objects. We can check the resolution of this imagery. If I right click and go to properties, take a look at that raster information again, it's telling us that my cell size is 0.3. And if I expand the spatial reference, then my unit is meters. So about 1/3 of a meter, 30 centimeters. Okay. All right. Now, again, voila, we've run this model on this imagery now using the same process as we just did. In your outputs geodatabase is this trees from NAPE 2024. I'm going to either right click and say add to current map, or I could again just drag and drop. And so let's take a look at these outputs. So this was a layer that I ran on just the Olin library extent here. Turn that back on. Okay, so right here. It did kind of extend a little bit beyond, just like our building polygons did. And so, running the tree detection model on this lower resolution NAPE imagery for this extent took about 8 minutes. So not crazy, but again, not something we want to spend 8 minutes doing here in this workshop. Okay. All right, and so then let's just take a look at one more model. I'm actually not going to have you download it unless you want to. But again, we're going to do the little cooking show approach. Going back to the web browser and our Living Atlas page again, I'm going to have you search for this time prompt. And what we're going to look for here, I don't think it's this one. Let me see. Do do. Okay, I don't know why prompt didn't show up. This prompt didn't show up, but we're looking for the prompt-based segmentation model here. So this is another one you can try. And the cool thing about this model is that it's not designed to find any one thing. What it is designed for is to take a prompt from us, the user, and then find that type of object. So you could like show it imagery of an airfield and say, find airplanes, and it would like try to find all the airplanes. One of the parameters for this model is prompt, where you would actually type in that prompt. So imagine that we are running this model. It's going to give us arguments just like this. One of the arguments is going to be prompt. So imagine we're back to our bike rack area here. So kind of zooming in. I'm going to turn off that NAPE imagery that we brought in, and I'm going to specifically show this Olin half-inch imagery where we can really see these bikes pretty well. Okay. So if we ran this model and we said, okay, running it on a prompt of bike, it would take not very long. It actually just took me about 30 seconds for this one. Back to the catalog. I'm going to say bikes from half inch from our outputs geodatabase. Right click, add to current map. Okay, now this is going to be a raster again. Results, okay. Not perfect, but it did find some of these bikes. It completely missed some pretty obvious other ones. So we'd probably want to tweak, run that again, see if we could get a little bit better results. But this was a pretty fast one just for this tiny area on the half-inch imagery. It took about 30 seconds. Okay. Now, the last thing I'll say is that, again, I just want to reiterate that this is rarely going to be like the end of your process here. It's probably going to be more like the beginning. A good use case. Every year or so, WashU has to report the amount of campus that is covered by tree canopy. So what we do is we take this high resolution imagery that we gather by drone. We use a few of these models, tree detection, land cover, so on and so forth. We combine all these outputs. We know the outline of campus too. So if we have polygons that represent tree canopy and we have a polygon that represents the area of campus, we can do a little tiny bit of analysis, just a little math really, and we can determine that percentage of tree canopy and report that to the organization that provides those designations. All right. So lots of use cases for this stuff. Again, just play around with it, tweak the models a little bit, And, hopefully you can get some solid results that will allow you to study whatever it is you're wanting to study. Okay, so that's going to wrap the demo portion. What other questions do you have to wrap up on the models, accessing them, getting input, so on and so forth?
I made a point thinking to change the parameter. I
Yes.
the square shaped tree detection.
You got the square shaped one. Okay. Okay. You know what? What I'm thinking here is I may have referenced the wrong model. So I might have pulled a different model when I was running my pre workshop. Um, Let me just go back to the model page because I thought the model was tree detection. Oh, you know what? I'm so glad you asked because the model actually that I used is called tree segmentation, not tree detection. So what I had you download kind of erroneously in this workshop was tree detection. Here's tree segmentation, and here's tree detection. So tree detection is going to give you these these like square or rectangular polygons, tree detection. Tree segmentation is what I ran the sample on, and that's going to give you those nice kind of canopy covered, colored shaped shapes. Thank you for asking. Just to repeat for the folks on Zoom, a user here in the room ran tree detection and was getting the square outputs. And that's because I had mistakenly said the tree detection model when really, when I ran this ahead of the workshop, I had run the tree segmentation model. So my bad on that. But again, the tree detection model, since it just does the squares, might be a little bit faster, I'm guessing, because it's not like trying to isolate those canopy shapes.
Yeah, it did,
Didn't take that long.
but it's,
Okay.
it's found exactly the same things that because it's just a one-to-one, there's one box on my layer for like one lobby, one row.
I
So
see.
the detection is the same thing, it's just the output.
Gotcha. Yeah. So just reporting for the room, it found most of the same shapes that the tree segmentation model did. They are just kind of in squares and not these tree blobs. All right. So let's go ahead and wrap it up here. Thank you so much for attending. Feel free to hit me up if you have any other questions. So thanks again. Thanks everybody on Zoom. And please let me know how this goes if you decide to use it in your own work.